Okay, exercise 5 says a furniture manufacturer makes tables and chairs. If a table takes 20 hours of labor and a chair takes 5 hours of labor to make, find every combination of tables and chairs that can be produced by 10 workers, each working a maximum of 40 hours per week. Looks complicated, but as the advice went earlier, read the problem carefully and know what you need to solve for and what you are given. Well, we're given some information. We're given how long it takes to make each item and how much time there is. There's 40 hours, 10 workers, so that's 400 hours. If I have 400 hours to work with, how many tables can I make? How many chairs can I make? And what are the combinations therefore? Well, the best way to show the combinations therefore would be to graph it. So what we're going to do, if I can find a piece of paper, there we go. Here's a piece of paper here. Okay, so I've lost my notes. I'll have to make this up as I go along. Okay, so 20 hours of labor for one chair. So one chair, 20 hours of labor. 2 chairs, 40 hours. 3 chairs, 60 hours. In other words, 20 times the tables will give me the number of hours I spent working on tables. It takes 5 hours of labor to make a chair. So if I add to that 5 hours for every chair, or 5 times the chairs, that all has to be less than or equal to 400 because that's the number of hours of labor I have. So if I put values in for t, I can figure out what the value should be for 5. Let's say, for instance, I put in 0 for t. I'm not making any tables. How many chairs can I make? Well, I can make 400 divided by 5. 80. I can make 80 chairs if I don't make any tables. So I'm going to represent this on a graph, and in order to represent this on a graph, I'm just going to have to pick one variable for the y-axis and one for the x-axis, and I've chosen to put the chairs on the y-axis and the tables on the x-axis. And so if I can reformat this in slope-intercept form, this is going to be a linear function, I can tell already, because there's nothing squared or anything. So if I'm going to solve for c, I will just subtract 20t from both sides, and I'll get 5c is less than or equal to negative 20t plus 400. And then I'll divide both sides of this inequality by 5, and I get c is less than or equal to negative 4t plus 80. So that is the old y equals mx plus b format for a linear function, where the slope is given here, negative 4, so it's going to be a line that's shaped like this. It's going to be a pretty steep one too, because it's negative 4. And b is my y-intercept, so 80 then is my y-intercept, so that's 80 right there. And I know it's going to be a negative slope of negative 4, so it's going to go down 4, 1 over, down 4, 1 over, down 4, 1 over. So I know that it's going to go over 1 for every 4 it went down, so this is actually going to be 20. And so that's my line. Question is, what's going to get shaded in? Well, what gets shaded in then is everything, including the line itself, so we could do the solid line. We can't produce negative tables or negative chairs, so it's this area here. So the answer then is all those combinations that are given within this shaded area of the chart. So 80 and 0 would work, so that combination is 0, 80. But then again, you could do 79 as well. You would just have some extra labor left over. It said here every combination that can be produced by these people working a maximum of 40 hours per week, so they could take some time off or something to make less. So 0, 80 is the most number of chairs, all the way down to 20, 0, which is the maximum number of tables. Let's show that up there. That's the maximum number of tables that can be made, 20 hours each, 20 of them, that's 400 hours. And all these combinations in between given by the shaded area here. Now I should mention that the answer key says this wrong. The answer key will give you things like 179, 176, and 272 and 368, and these are all along the line here, but the answer key ignores the fact that you could just not spend all your labor, because after all it is a maximum question, and the maximum is given by the line, but the shaded area is also a possible combination.